I saw this question on YouTube. I have my ways to do it. Two methods. I believe my method is better, so I would like to share with you. Now, given sin x equal to I, we're looking for x. From this, I know I can find cosine x, which is equal to plus or minus the square root 1 minus sine square, right? 1 minus sine square. Sine square is sine square is negative 1 there, so plus 1. So equal to plus or minus 1, plus or minus root 2. And then from the Euler's formula, e to the power xi is equal to cosine x plus I sine x. Depends. Therefore, this is a cosine, this is a sine, that is equal to plus or minus root 2 minus 1. Yeah. So from this, I know that xi is equal to natural log of plus or minus root 2 minus 1. Yeah. I know that xi is a complex number. Therefore, this is equal to a plus bi. And a, b are real numbers. And from this, I can know that plus or minus root 2 minus 1 is equal to e to the power of a plus bi, which is equal to e to the power of a times cosine b plus I sine b. Now, this is a complex number, has no imaginary part. So this complex number, the imaginary part must be 0. So this says sine b must be 0. So this means that b equal to 0 or pi. B equal to 0 or equal to pi. So we discuss the case separately, which means that plus or minus root 2 minus 1 is equal to e to the power of a times cosine b. Right? This is 0. Right? Then this one has two cases. Right? When b is 0, this is positive because e to a is positive. A is a real number. This is always positive. So therefore e to the a must be positive. This is root 2 minus 1, right? The other case, when b is a minus pi, b is a pi, if a b is a pi, cosine b is a negative 1. If this is negative 1, this is positive. This is negative 1. So this side must be negative, right? So it's a negative root 2 minus 1 is equal to negative EA. Therefore, e to the power a must be root 2 plus 1. Well, I hope you can follow, right? This means that a is equal to natural log root 2 minus 1. Now, natural log root 2 minus 1 could be written this way. Natural log root 2 minus 1 is equal to natural log 1 over root 2 minus 1 negative, right? So this one is equal to negative natural log root 2 minus 1 times the root 2 plus 1 times the root 2 plus 1 equal negative natural log. So this is equal to root 2 minus 1. So I end up with root 2 plus 1. What I want to say that this one is equal to this, not negative that. So this one is equal to negative natural log root 2 plus 1 when b is 0, right? And the other case is this, right? Is equal to natural log root 2 plus 1 when b is pi. So we have two cases for a. And xi is equal to a plus bi. So this means that x is equal to b minus a, right? Simply b minus ai. Yeah. Now we know b, we know a, right? So x, the two cases. When b equal to 0, when b equal to 0, a is this. So x equal to natural log root 2 plus 1, right? Negative that become positive. The other case is that when b is pi, therefore this equal to pi minus a. A is this, right? I forget I. Yeah. I log root 2 plus 1. This is a, right? Yeah. And plus the multiple of 2 pi. So to make a general solution, then n equal to real numbers. No, n equal to integers, I'm sorry. So this becomes the solution to our equation by using this method. And it's very neat, very clear, very straightforward, very good. Now, this is the first method. Second method is that I have another video that showing that cosine x equal to I. Then the solution is x is equal to half pi minus I natural log root 2 plus 1 plus 2n pi. Now, okay, if you haven't seen this video, you can go see it. You see the web linkage is below. You can see that solution in detail. So the second method is that I'm using this given result. I can find a sine x equal to I. Okay, by using now the first is that sine half pi minus x is equal to cosine x, isn't it? If this is equal to I, then I just using this result taken away from half pi, right? So therefore, x is equal to Yeah, sine, well, I should just half pi minus sine, right? There's just half pi taken over this way becomes I natural log root 2 plus 1 plus the multiple. This is the same. So that's one solution. Yeah, this is one solution, right? For for sine this equal to I. Yeah. The other one is that sine half pi plus x is equal to cosine x equal to I. If this is x, then half pi plus that will be the solution to the sine x equal to I. So therefore, plus this one plus this one plus this, half pi plus this becomes well, half pi plus x is equal to pi, right? Is equal to pi minus I natural log root 2 plus 1, yeah, plus 2n pi. See, that is the other solution. This is the other solution for sine a solution to I. Yeah, that's correct. I hope you can follow that. Given that cosine x equal to I is known, you can see my video in the linkages below. Then, if given that the solution to cosine cosine x to is equal to I, if the solution is given, then we can find the sine x equals I just simply by using half pi taken away from this, or half pi plus that becomes the other solution. I hope my explanation is is clear, and I hope you like it too. Thank you.